All right, working on problem number 46. It's asking us to find the vertical asymptote. Now I'm going to do this a little bit the short way. One thing you need to be careful of is to make sure that the top and the bottom don't cancel, because that creates a hole, not a vertical asymptote. So what we need to do is factor out a -2 on top. So factor the top first. And there you go. There's your phone flip for the day. So the -2 comes out, x squared plus x minus 2. All right, and then the bottom we factor that, and you get x minus 3, x plus 1. Factor the top again, -2, x plus 2, x minus 1, x minus 3, x plus 1. Nothing cancels. Therefore, there are no holes in this graph. Okay? No holes. So that means vertical asymptote is where the denominator equals 0. Take these two things, set them equal to 0. X equals 3, x equals -1. Those are your vertical asymptotes. Denominator equals 0. For number 47, it asks us to identify the holes. The top is the same exact thing as the top up here, so we know that factors to -2, x plus 2, x minus 1. Factor the bottom, multiplies to give -6, adds to give -1, so x minus 3, x plus 2. Now, right here, you can see that we have a common factor on top and bottom. X plus 2 equals 0, x equals -2. That is a hole. Okay, so if you have two factors that cancel each other out, set them equal to 0, solve it, that gives you the hole. Number 48, I'll do this one really quickly. Horizontal asymptotes, remember there's 3 rules. Top less than bottom, y equals 0. Top greater than bottom creates a slant instead of a horizontal asymptote. If the degrees are the same, then we divide the leading coefficients. Well, look at this. This one has a degree of 2 on top and a degree of 2 on bottom, which means the degrees are the same. So now we simply divide the leading coefficients. So 2 over 1, so your horizontal asymptote here is just y equals 2. Okay? Number 49, identify the x-intercepts. So we have x minus 1 over x squared minus x minus 6. We just factored the bottom. Okay, so we know the bottom is x minus 3, x plus 2. The top is x minus 1. The only reason we need to do that is to make sure nothing cancels. Okay, nothing cancels. So now you take the top, you set it equal to 0 to solve it. X equals 1. That is your x-intercept. Okay, set the top equal to 0. That's how you find your x-intercept. 50. I know I'm going kind of quick through these. But if you listen to what I'm telling you to do, that tells you how to do each thing. So far we have vertical asymptotes. Vertical asymptotes are denominator equals 0. Holes is where you factor them and you look for things to cancel. Horizontal asymptote, there's 3 different rules. Top less than bottom, y equals 0. Top greater than bottom, no horizontal asymptote because that creates a slant. If the degrees are the same, you simply divide the leading coefficients. X-intercepts, set the top equal to 0. You might want to go back through and make some notes about all those different things. 50. 50 asks for domain. With everything else, you need to factor, because if there's a hole, that's going to create a domain issue. So, factor the top. This factors to x minus 2, x minus 1. The bottom factors to 4 times x minus 3. Nothing cancels, so there's no hole. So the way we find out where the domain equals 0 is take the denominator, set it equal to 0. 4 times x minus 3 equals 0. Divide by the 4. X minus 3 equals 0. X equals 3. That creates a problem. That is where our domain does not exist. So -infinity to +3 union +3 to infinity. Now, if you're in my class, you're not going to need to worry about problem number 51. That's not going to be an issue. 452. Find a graphing calculator, type it in exactly like you see it, and graph it, okay? You know that there's nothing being added on the outside, so that means our Horizontal asymptote, it's going to be at y equals 0. You know this base is a 2, so you know it's going to be a growth. Okay, plug in 0 right here, and that makes this 1. 4 times 1 is 4, which makes it do that. Okay, so this thing's going to be like curling and going up. But type it into the calculator, look for your y-intercept, and simply match the two graphs up. Match them point to point. 53, it says identify the domain and range, and then sketch the graph. Remember, this is the one that you have to flip. But if it says natural log, you can type it into the calculator. So again, type that into the calculator and match them up. That's it. Don't make it more complicated than it is. Number 54 says use a calculator to solve. This is change of base. Log of 4.6 divided by log of 4. Type it into the calculator. It's going to tell you an answer like 1 point something. Okay, I don't have a calculator on me, otherwise I would do it. But type that into a calculator. Okay, change of base for number 54. Number 55. 3 to the 3n equals 3 to the 3n plus 3. Well, guys, if we're going to solve a problem like this, this means the bases have to be the same. Our bases are the same. So 3n equals 3n plus 3. Then you just simply solve for n. So this is 0 equals 3. That cannot happen. 0 never equals 3. No solution. Okay? But if you have to get the bases the same. So here's what I'm talking about. If you look over at problem number 56, 36 to the 2m equals 1/6 to the negative 3m minus 1. You've got to get the bases the same. Looking at this, you know the base is going to be 6. So 6 to the something, and the 2m's chilling up top. 6 to the something, the negative 3m minus 1's chilling up top. Okay? 6 what gives me 36? 6 squared. This one is a little bit weird, but it's 6 to the negative 1 because it's a fraction. If it flips upside down, then you know it's going to be negative. Then 6 to what power gives me 6? That's just going to be 1. Multiply 6 to the 4m equals 6. Distribute the negative 1, 3m plus 1. Now we solve. Bases the same, cancel them out. 4m equals 3m plus 1. Subtract 3m. m equals 1. That is your solution. So in a problem like this, make sure you get the bases the same and then solve it. That'll be it for